In this video, we are going to see about the binary search tree. This binary search tree is also known as ordered binary tree. It is also known as ordered binary tree. So it is a variant of binary tree in which the nodes are arranged in any order. Okay. So here nodes are arranged in an order. So in binary search tree, all the node in the left subtree have the value less than the root node. Okay. In a binary search tree, all the nodes in the left subtree have the value less than the root node. And next, all the nodes in the right subtree have greater than or equal to that root node. Okay, it is greater than or equal to root node. And this same rule is applicable to every subtree in the tree. It is applicable to every subtree in the tree. So for example, consider this tree, and what is the value for the root tree? It is 39. And we will check the left subtree. So the left subtree, it contains the left subtree value was 29. So 27. Then if you check the left child of the 27, it is 18. It is less than 27. Then left of 18, it is 9, less than 18. And if you check right of 9, it is greater than 9. Okay, so right child is greater than the root. And here if you check 21, it is greater than the root 18. Then see, it is 19. It is less than this particular node and same time greater than this 18. Okay, then if you check 29, so it is a right child for the 27. It is greater than 27. Then if you check the 28, it is less than the 29 because it should be less than, left child should be less than the root. Then if you check 36, so it is greater than the 29. Okay, so whatever values we are using in the left child, it should be less than the root. Okay, and if you check the right child, right subtree, it is greater than the 39. Say 40, 45, 54, 59, 65 and 60. And whenever you are inserting the left child, it should be less than the root. So here you can see it is 45. So check the left child, it is less than the 40. Okay. So it should follow the rule that the left child value should be less than the root node and right child value should be greater than the root node. So the properties of binary search tree, the left subtree of the node n contains the value that are less than the n value. Okay, if the left subtree of the node n contains the value that are less than the n value, and the right subtree of the node n contains the value that are greater than the n value. So both the left and right binary trees also satisfy these properties, and thus the binary search tree. So both should satisfy these properties. So it is called as the binary search tree. So for example, consider some sample trees are given. We need to identify the particular tree is binary search tree or not. So we will check here. So 21. So root node is 21. So check the left child. It is greater than 29. 21. So it is not a binary search tree because so the left child of 21 is greater than, it is 21 is greater than 22. So it is not a binary search tree. And we will check the next one, this one. 21, the left child is 20. So it is less than the root node. Then if you check the right child, it is 28. It is greater than. Then if you check the left child of the 28, it is 27. It is less than. Then it is 39. So it is a valid binary search tree. Then we will check here. The root is 21. The left child is 19. So it is right. Then left child of the 19 is 17. So it is less than. Then if you check the right child of the 19, it is greater than 42, and same time it is greater than this 21 also. So this is not a binary search tree. So if you check here also, it is 21 greater than the root node, but it is 15, it is less than the root node, right? So both are not in the particular constraint, so it is not a binary search tree. Then the operations of binary search tree. So here we are doing the operation searching, insertion and deletion. So here the complexity, it is worst case as well as the best case. Okay. So when it is a worst case, when is a best case? If the elements are given in order, that is left subtree contains the values less than the root, and right subtree contains the values greater than the root, means it is the best case. So when you are doing the insertion, deletion and searching, the complexity is big O of log n for both the operation. And for the worst case, okay, so the height of the binary tree is n. Okay, the height of the binary tree is n. So that is if the elements are in the left scoot, that means it contains only the left child. And if the nodes are in the right side, that is it contains only the right child, that is a right skew. So if the tree is like this, it is a worst case. So for that, the search operation, the complexity is big O of n, and insertion it is big O of n 1. It is very easy, right? It can insert like this or it can insert like this. And for delete operation, it is big O of n. So we have to search every element, which element. So if you want to search the 65, means every element we need to check. So the complexity for the delete operation is big O of n. Then next we will see the construction of binary search tree. So here the elements are given. So what is the first element? So the first element is 45. So we are considering that as a root node. The next, what is next element? It is 39. We have to check whether 39 is greater than 45 or less than 45. It is less than 45. So we have to insert as a left child for the 49. The next we have to check next element, it is 56. So first we have to check with the root node. So it is greater than the 45 or less than 45. It is greater than 45. So we are adding as a right child for the 45. The next element is 12. So first we have to check with the root node. It is less than the 45. So we have to check with the child of 45. It is 39. We are checking 39 is greater than or less than the 12. It is greater than the 12. So we can add that as a left child. It is a left child. Okay. The next element is 34. Again the same procedure we have to do. So first we have to check with the 45. It is less than 45. So we are moving to the left subtree. Then we are checking with the 39. It is less than the 39. So we are moving to the child of the 39. And we are checking with the 12. It is greater than the 12. So what we are doing? We are inserting as a right child of the, okay, we are inserting that as a right child of the 12. Then next element is 78. So first we have to check with the root node. Okay, we have to check with the root node. It is greater than the 45. So we are moving to the right subtree. Okay, so here the element is 56 and we are checking with the 56. It is greater than the 56. So what we have to do? We have to add that as a right child of the 56. The next element, it is 32. So we are checking with the root, it is less than 45. Then we are checking with the 39, it is less than 39. So we are moving to the left child. We are checking with the 12, it is greater than 12. So we are checking with the right child of the 12, 34. We are checking with the 34, it is less than 34. So it is the left child for the 32, left child of the 34. Then we can check the 10. So we are checking with 45, it is less than 45, so we are moving to the left subtree. Then we are checking with the 39, it is less than 39, we are moving with the left subtree. Then we are checking with the 12, it is less than 12, so we are adding that as the left child of the 12. We are adding 10 as the left child of the 12. Then we are checking with the 89. So it is greater than 45. So we are moving to the right child, right subtree. It is 56. We are checking with the 56. It is greater than the 56. So we are moving with the right child, 78. Then we are checking with the 78. It is greater than 78. So we are inserting as a right child of 78. The next one is a 54. So we are checking with the root node 45, which is greater than 45. So we are moving to the right subtree. We are checking with the 56. It is less than 56. So we are inserting 54 as the left child of the 56. Then we are checking with the 67. So we are checking with 45, it is greater than 67. Then we are checking with the 56, it is greater than 56. So we are moving to the right subtree. We are checking with the 78, it is less than 78. So we are adding that as the left child of the 78. The next last one is the 81. We are checking with the root node. Okay, we are checking with the root node. It is greater than 45. So we are checking with the right subtree. It is 56. We are checking with 56. It is greater than 56. So we are moving to the right subtree. It is 78. We are checking with the 78. It is greater than 78. So we are moving to the right subtree. It is 89. It is less than 89. So we are adding as a left child of the 89. So this is the procedure to do the to construct the binary search tree.